Okay, this video is going to show you how to find two angles in the interval of 0 degrees is less than theta, which is less than 360 degrees, that make the equations true. So our first one is going to be cosine of theta equals 7 over 25. So I know that cosine is really the adjacent side over the hypotenuse side. I know that. So this value is positive because we don't see a sign here. There is no negative. And so for cosine, remember, cosine is really our x value because it comes first, and our sine is the y value. So cosine is positive when we're going to the right. So that's either going to be quadrant 1 or it's going to be quadrant 4. So again, cosine is positive when we go to the right. That means that both of our answers to the angles have to be in quadrant 1 and quadrant 4. So I'm going to erase this part here. Okay, so now what I'm going to do is I'm going to draw my triangle. So I'm going to draw something like this. And so same thing here. And so now what I have to do is I have to label these. So my adjacent side is going to be this side right here. So this is going to be 7 because this is the angle of beta here. So this has to be 7. And then the 25 is the hypotenuse. The hypotenuse is across from the 90-degree angle right here. So I'm going to erase that, and then I'm going to put this. So on this triangle, the hypotenuse is here. My adjacent side is the same. So now what I have to do is I have to find this angle here. I know my two sides, so this means that I have to use the inverse. So on this problem, I'm going to have to use the inverse because we know two sides. We have 7, we have 25. That means that we're going to do the inverse cosine of our angle, and we know that that's equal to 7 over 25. So when you do your inverse cosine in the calculator, remember, you have to be in degrees, number 1. And number 2, you have to click that button that says INV in order to get your inverse to choose cosine inverse like this. Okay, so this is what you have to put in your calculator. And when you do that, you should get a beta value of 74 degrees. And so what that means is that this angle here is 74, and this angle here is 74. So that's what we found out from here. And now what we need to do is we need to find the two angles that make this equation true. So here we are in quadrant 1, and if you remember, in quadrant 1, our theta value is equal to our beta value. So this one is easy because beta is equal to 74, so that means that angle 1 is equal to 74 degrees because theta is equal to beta. For angle 2, we are in quadrant 4. So quadrant 4, we use theta equals 360 minus beta. So what I'm going to do is I'm going to do theta equals 360 minus 74 because we know that the value for beta is 74 from here. So that means that theta is going to be equal to 286 degrees. And so angle 2 is equal to 286 degrees, again, because we used this formula here. So this is how to find the two angles in the interval that we had to make this equation true. I'm going to do a second example when we have a negative here. So I'm going to do the sine of theta equals -8 over 17. So again, first thing I'm going to draw, and we have a negative here. So sine, again, is our y value. So sine is negative when we are going, so sine is negative when we're going down. So when we're going like this, so that's either going to be quadrant 3 or quadrant 4. That's the only time when our sine is negative. So now I'm going to draw my triangles. And we know that sine is equal to the opposite side over the hypotenuse side. So if this is my beta angle here, then my side that is opposite is going to be here. So this is 8. I'm not going to put -8 because, again, we're talking about length, and length cannot be negative. So this needs to be positive. And same thing on this side. And then the hypotenuse, which we know is always across from the 90-degree angle, is 17. So now I have that set up. And now, because I have two sides that I know, I have to use the inverse again, just like we did on the first one. So inverse sine of our angle, which we don't know yet, is equal to our 8 over 17. Again, not -8. We'll work with that later. And when you do this in your calculator, again, you have to be in degrees and you have to click the inverse button. We have beta equaling 28 degrees. So now that we have that, we are much closer to finding our actual angles. So I'm going to highlight this part. So now what I have to do is I'm going to find my angles. Sorry about that. Okay, so angle 1, we are in quadrant 3. So quadrant 3 is theta equals 180 plus beta. So what I'm going to do is I'm going to do theta equals 180 plus, actually, I'm going to do that work over here instead. So theta equals 180 plus, our beta was 28. So that means that our angle is equal to 208 degrees. So this is 208 degrees because of the work that we did here. Angle 2 is in quadrant 4. In quadrant 4, we have to use the equation theta equals 360 minus beta. So again, if beta is 28 degrees, I'm going to subtract 28, and theta is actually going to be equal to 332 degrees. So that's the measure of, that's the measure of our second angle. And that's because we did this work that's here. So again, the biggest tricky part about this one is the negative. So figure out when sine is negative. That's how we knew it was the third and fourth quadrants. But all throughout the problem, you're still using a positive value because we're talking about length, and length cannot be negative.